Hi there and welcome to another video for the AQA Linear GCSE Higher paper. In this video I will start work on practice paper 3, the non-calculator paper. Right, let's start straight away. First question. We are told the table shows driving distances in kilometres, so let's highlight that, between 5 towns. For example, it is 250 kilometres from Cardiff to London. How do we get that from the table? Well, the intersection of the Cardiff column and the London row is 250, so that tells us it's 250 between the two. Now, Trevor makes this journey Edinburgh to Manchester, so Edinburgh to Manchester 330, Manchester to Cardiff, so Manchester to Cardiff 280, Cardiff to London, so Cardiff to London, we know that's 250, and London to Edinburgh 640. And how far does he drive? Well, all you've got to do is add these up. Remember, you're not allowed to use a calculator here. So 330, 280, 250 and 640. Add these up in a column method. Add all the zeros, you get 0. 4 and 5 is 9. Add 8 is 17. Add 3 is 20. Put down the 0, carry the 2. 2 and 6 is 8. Add 2 is 10. Add 2 is 12. Add 3 is 15. So it is 1,500 kilometres is our answer. Okay, next question. John drives from Aberdeen to Edinburgh. His average speed is 60 kilometres an hour. How long does the journey take? Well, firstly, Aberdeen to Edinburgh. Let's just read off our table how far that is. Let's get ourselves a mark by doing that. Aberdeen to Edinburgh, it's 180. Okay, so it's 180 kilometres. And you should also know that speed is distance divided by time. You might have seen that triangle in science, or you would just remember something like speed is given in meters per second, which is distance divided by time. So speed is distance divided by time. If you want to work out how long the journey takes, if you want time rearranging this must be distance over speed, or how sometimes you're taught in science, cover up the time and it's distance over speed. So write down your formula that you need. Time is distance over speed, so therefore time is your distance, which is 180 kilometres, divided by your speed, which is 60 kilometres per hour, and you will get 3 hours. So your answer is 3 hours for 2 more easy marks. Okay, next question. It's a best buy type of question. Andy sees 2 offers on potatoes, Joe's spuds and Murphy's spuds. Which is the best buy? You must show your working. Okay, this is a very straightforward question. It's just about showing our working. I'm going to go down this side of the page just so I've got more space, but you could fit it in the appropriate amount. So firstly, start off with Joe and do some working. It's £10 for 30 kilograms plus 25% extra free. Okay, so it's £10 and you get 30 kilograms and 25% extra free. So you get 30 and you get a 25% increase, so it's multiply it by 1.25, or just work out a quarter of 30. A quarter of 30 is 7.5, so therefore adding this on, it would be 37.5 kilograms you would get for your £10. You would get 37.5 kilograms. Okay, so that's how much you get for Joe. For Murphy, you get, for the £10 again, so for the same amount of money, you get 32 kilograms plus 20% extra free. Well, you would get 32 multiplied by 1.20. Okay, or you can think of it as, what is 20% of this? Well, what's if you want to work out 20% of 32, let's say, it's going to be easy for you because it's simply the same thing as 0.2 multiplied by 32, which is the same thing as if I make that a 2, times that by 10, I would divide that by 10. It must be that to balance it out. Okay, so therefore it would be 6.4. So therefore, adding 6.4 to this, it would be 38.4 kilograms. So for £10, you get 37.5 of Joe spuds. For £10, you get 38.4 kilograms of Murphy spuds. Therefore, your conclusion is Murphy's is better. And you could state get, I don't know how much is that? That's 0.9 kilograms more. 0.9 kilograms more for your £10. Okay, so this was simply a case of being able to work out 25% of 30 and work out 20% of 32, adding it on and showing that for your £10 you get more of Murphy's. Question 3. AB and CD are parallel lines. AB and CD are parallel lines. We know we are going to use our angle laws of parallel lines. Remember, there are many different ones. Those are alternate, they're equal. That's one of them. That one and that one are corresponding and they're equal. And that one and that one are called interior and they add to 180. Okay, so we know these rules are in play here. Let's just see what we can do with this. Write down the value of angle X. We want this angle here. Give a reason for your answer. Well, clearly X and this angle here are corresponding. So the answer is 59 degrees. And all you have to say is the word corresponding. And you're done. That will get you your 2 marks. Okay, next question. Work out the value of angle Y. Okay, so let's go to Y. What's angle Y here? We need to work out that angle there. Well, we know it's corresponding with that angle there. Okay, but what is that angle? That angle must be 180 subtract 112 because these are on a straight line and that would be equal to 68 degrees. Therefore, it must be 68 degrees. So show your working. You would state that 180 subtract 112 is 68 degrees and therefore state that Y equals 68 degrees and then write down your reason it is corresponding. And that would easily get you your 2 marks. Question 4. K, Q and R are 3 prime numbers between 10 and 25. Work out the values of K, Q and R. First thing I do, before I even read what this is about, I would list the prime numbers between 10 and 25. So 10's not prime and 25's not prime, but let's list the primes in between. 11 is, 12 isn't, 13 is, 14 isn't, 15 isn't, 16 isn't, 17 is, 18 isn't, 19 is, 20 isn't, 21 isn't, 22 isn't, 23 is, and 24 isn't. So here are our list here. And basically, we want 3 of these such that if you add 2 of them together, you get twice the other one. So this one here must be the smallest of the 2, I would have thought. So let's just try R being 11. Therefore, 2R would be 22. Can we find 2 primes that add up to 22 from these here? Well, no, we can't. So it's no good in this case. So let's try R being 13. 2R would then be 26. Can we find 2 of the primes that add up to 26? I can't. So let's try R is 17. 2R would then be 34. Can I find 2 primes that add up to 34? Well, yes, 11 and 23 do. So therefore, I could have R being 17 and I could have K being 11 and Q being 23. And that would certainly get me my answer. Do note that K could be 23 and Q could be 11. They could be swapped, but R would need to be 17. So you get this by trial and error. 3 marks there, just by a bit of thinking. Very, very easy. Okay, question 5. Roxy is doing a survey to find out if boys or girls send more texts. Design an observation sheet to collect her results. Okay, so an observation sheet is just something that you record your scores on. So it's not something you necessarily ask someone. So you just might have something like this. You might have something like number of texts per week. Do give it a time. that would be your heading of this column here, and you might have boys recorded there and girls recorded here. Okay, and it might be something something along these lines, something like this, where what you could and what you might do is, for example, when you use this, you might just ask the first boy, and the first boy says, I send 7. Then you ask the next girl, and she says 2, etc. And you just keep a list like that. You might even, if you want, have a total column, the final column. You might have a total column here. Okay, so it's just a way for you to collect the data if you were asking people on the street, let's say. Okay, so let's not confuse this with a survey. This isn't a survey, it's an observation sheet. An observation sheet is just something where you can record your findings of an experiment or a survey. So it's something you would design so that you could collect information. So this is a nice easy way to collect information. Usually a two-way table is what they're looking for here. Question 6. Work out the circumference of a circle, radius 8. Give your answer in terms of pi. Do read that part there. Now, just a bit of revision here. If you have a circle, here's the center. This line here is the radius. There are two things you need to know. You need to know the circumference, which is given by the formula 2 pi r, and you need to know the area, and it's given by the formula pi r squared. Sometimes if you're struggling remembering these, what I tend to remember, area's unit is centimetres squared. Squared there helps me remember pi r squared, and the circumference, I just bring the 2 down in front of it, so I would have 2 pi r. That's how I remember it, a quick easy way. Anyway, you have the radius is 8 and you want the circumference in terms of pi. So write your formula. C is 2 pi r, so C is therefore 2 pi times 8, and with this you can just multiply the numbers. 2 times 8 is 16, and leave the pi left over. 16 pi. That's what it means to leave your answer in terms of pi. It means leave pi in the answer. Don't actually multiply it out and decimalize it. Okay? Okay, next. Question 7. A and B are odd numbers. Is A plus B odd, even, or could it be either? With these questions now, I would always suggest you just think of a few examples if you can't see straight away. A and B are both odd, so pick 2 odd numbers. 3 plus 5, you get 8. Let's pick another 2. 11 plus, let's say, 17, you get 28. That was even, that was even. Okay, 1 plus 3 is 4, that's even. It seems to me that if you add together 2 odds, you get an even. Another way of doing it algebraically, even if you wanted, an odd number could be written in the form 2n plus 1. Okay, and another odd could be 2m plus 1. Okay, for a different n or m. If you add these together, you get 2n plus 2m plus 2. You can see that 2 divides into all of those. It's a multiple of 2, so it's definitely even. But you could also get it by examples. Even is your answer in this case. Next question. Again, let's do examples and let's see if we could prove it as well. Is A times B odd, even, or could it be either? So is an odd times an odd, even, or either? So let's do a few. 3 times 5 is 15. Okay. 7 times 11 is 77. I don't know. 1 times 9 is 9. Okay, so it seems that odd times odd gives you odd. And let's see if we can prove it algebraically. Take an odd number, 2n plus 1. Multiply it by a different odd number, 2m plus 1. Multiply it out, see what you get. That times that would be 4nm. That times that would be plus 2n. That times that would be plus 2m. And that times that would be plus 1. Now this thing here is certainly an even number because it's in the 4 times tables, the 2 times tables, and the 2 times tables. So that's definitely an even number. So you could write it as 2 times some big number and plus 1. And anything of that form is definitely odd. So therefore the answer is odd. Again, you could have simply got that by examples. Next question. A test is taken by 20 students. Work out an estimate of the mean mark. Okay, let's just, before I launch into this, I'm just going to take a second over on the side here to just explain what this table means. It's telling you that at 0 to 4 marks, no people got that. Okay? Also, it's then telling you that between 5 and 9, 4 people got that. So let's say one person got 5, one person got another 5, and then there was 2 8s, let's say. Okay? Let's say to represent that. And here, no people got that. Here, 10 people got between 10 and 14. So there were 10 people, say there was 10, 10, 10, 11, 11, and 14, etc. like that. Imagine there was 10 of those people, etc. Now, how would you work out the mean of a set of numbers? Well, what you would do is you would add up this total here, and you would divide by how many there are. So the mean will be the total score divided by the number of people, right? Okay, well in this case we are not told the individual scores. Instead, between 5 and 9 we are estimating that 7's a good guess for the 4 scores there. So instead of 5 and 9, what we're doing is we're saying, well, let's just assume there was 4 7s because we don't know the scores, so let's estimate 7 is exactly halfway between the two. And here, instead of the actual 10, 10, 11, 11, 11, blah, 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 let's just estimate that we got 10 scores of 12. And similarly, the midpoint here, the midpoint here. If we want to work out the estimated mean then, so I'll call this a mean with a star, this is an estimated mean. Again, it's the total guess score, or estimate of the score, divided by the total number of people. Okay, now how do we add up 4 lots of 7? Well, we just do 4 times 7, which is 28. How do we add up 0 lots of 2? Well, 0 times 2 is 0. 10 lots of 12 is 120. 4 lots of 17, well, it's 4 times 10 is 40. 4 times 7 is 28, so it's 68. And 2 times 22 is 44. And then you add these up down. So in summary, when you see something like this, if you're working out the mean from a group table, you do the frequency times the midpoint of the group. Okay, add those up and divide by the total frequency. So let's go with this. 0 at 28 is 28. Add 120 is 148. Add 68. Well, add 60 is 208, and add the 8 is 216. And then add the 44. Add the 4 first. 220, so it'd be 260. So the estimate of the mean will therefore be 260 divided by 20, and what you can do is you can divide top and bottom by 10, so it's 26 over 2, and 26 over 2 is 13. And there you go, with some explanation as to why this method works over here. Okay, question 9. A square is drawn on one side of a regular hexagon. Let's remember, regular hexagon. Work out the size of angle x. Now, if it's regular, all the sides are the same. So if it's regular, all the sides of the hexagon are the same. Okay? That's the first thing. Now, if you've drawn a square here, then one of the sides is one of the sides of the regular hexagon. So the square must have these sides here in particular. So if we look at this triangle here, just considering that triangle, would you agree with me that it must be isosceles because that side and that side are equal? So this angle here must also be x. Right? Okay, it's 4 marks to get this question. Now, the one fact you need to know is you need to know what the interior angle of a regular hexagon is. There are 2 ways to do it. So let's divide up into 2 ways. The interior angle of a regular hexagon. Let's draw a hexagon first. Firstly, what you could do is pick one corner, draw lines to each of the other corners. Realise you have 1, 2, 3, 4 triangles, so the interior angles must add up to, of each of these must be 180, so 4 lots of 180 are actually 720. So therefore each particular one, if you divided each particular one by the 6 that there are 1, 2, 3, 4, 5, 6, 720 divided by 6, well 72 divided by 6 is 12, so 720 divided by 6 is 120 degrees. The interior angle must be 120, okay? So you could label that as 120 degrees and show where you got your working, namely by this here. Now the other way of doing it, just to quickly show you the other way of doing it, whichever you prefer, here's another hexagon, and what you should know is you should know that the exterior angles of any shape, these angles here, always add to 360. So the exterior add to 360. There are 6 of them, so each one in this case must be 60 degrees. If that's 60 degrees, then it's obvious that this must be 120 degrees. Therefore, interior 120 degrees. So either way to get you to the interior being 120. So therefore, you might call this angle y here. You could therefore state that y must be 120 degrees. Take away the 90 here for this circle. So it'd be 30. Okay, so this is 30 degrees. And therefore x, how would you get x? Well, you know that 2x must be 180, take away 30, which is 150. So 1x must be 150 divided by 2, which is 75 degrees. So the answer is 75 degrees. Now, to get the full marks here, show your working of the interior, label the interior, call this angle here something else like y, show how you get y by taking the interior of the hexagon, subtracting 90, and then show how you get the x using the fact that it's isosceles. You may even state isosceles there, just to show the examiner what you're doing. Okay, question 10. A ladder is 2.6 meters long. It is placed so that it reaches a window ledge 2.4 meters above the ground. How far from the base of the wall is the foot of the ladder? You will need the following information. Okay, so basically we're asked to find this missing length here. We have a right angle triangle. It is Pythagoras. We're working out one of the shorter sides. So let's call this x. X squared, we know, must be 2.6 squared. Subtract 2.4 squared. Do make sure you've identified this as being the shorter side, so it's the hypotenuse squared, take away the other side squared. You are told that 2.6 squared is 6.76. You are told that 2.4 squared is 5.76. Taking these away from each other, we're clearly going to get the answer of 1. So x squared is 1. X therefore is the square root of 1, which is 1. When you take square roots, you would get a negative answer, but clearly a length can't be negative. So x is therefore 1 meter. Question 11. Solve the following. For 4 marks, this is unbelievably easy. Let's expand the bracket. 2 times 3x is 6x. Subtract 2 times 1, which is 2. And that is equal to 3x plus 13. Now let's get all the numbers to the same side. Let's add 2 to both sides. So we would now get 6x is equal to 3x plus 15. Let's get all the x's to one side. Let's subtract 3x from both sides. So we'd have 3x is equal to 15. And then finally, let's divide both sides by 3. And we would get x is equal to 5. And that would be our answer. Before we move on, and we always do this, we are going to check it works. You must check. You don't want to lose marks on an easy question like this. 3 times 5 is 15. 15 take away 1 is 14. 2 times 14 is 28. On this side, 3 times 5 is 15. 15 plus 13 is 28. We've got this right. We tick it and we move on, and we don't have to check it later in the exam. Okay, question 12. Here is a spinner with 5 equal sides. The arrow is spun 50 times. The number of times the arrow lands on red is recorded. The relative frequency is plotted after every 10 spins on the grid. Okay, before we launch into looking at the question here, let's just think what this means. We've done 10 spins. The relative frequency is 0.2. Let's remember what the relative frequency is. Relative frequency. It is the number of times the thing happens, so it's number of occurrences of the thing you're interested in, divided by the number of trials. For example, okay, the relative frequency of red is how many times it landed on red divided by how many times you spun the thing. Okay, so it's kind of like the probability. Right, so if you know the relative frequency, say you know this, and you also know the number of trials, then couldn't you work out the number of occurrences by rearranging this formula? So the number of occurrences must be relative frequency times number of trials. Relative frequency times number of trials. Just rearranging this equation. Therefore, let's think what's happening here. After 10 trials, we have a relative frequency of 0.2. So the number of times we landed on red must be 0.2 times 10, which is 2. We must have had 2 reds. What about here? Well, we've had 20 trials and it's 0.25. So it's 0.25 times 20. Well, 0.25 times 10 is 2.5. So times 20 must be 5. What about here? Well, it's 30 times, this is 0. So let's just see how this is going. That would be 0.16, 17, 18, 19, and okay. So this here is exactly in between the two. So this is 0.65, let's say 165 times 30. And this one here is going to be 0.175 times 40. And this one here is going to be 0.2 times 50. Now we may not need to actually have to work these out. Let's have a look at the question now and see what it's asking. Show that the arrow lands on red 5 times in the first 20 spins. Well, we have done that. What you do is you do 20 multiplied by 0.25 and you get 5. So you do 20 multiplied by the relative frequency 0.25 and you get 5 times and you're done. Is the spinner biased towards red? Tick a box, give a reason for your answer. Now if this was fair, okay, and there's 1 red out of 1, 2, 3, 4, 5. So you would expect 1 out of 5 to be the probability. Over time, you would be expecting it to start going to 0.2. Now, as you're doing more experiments, it does seem to be trending towards 0.2. So I would say, is it biased towards red? I would say no. And I would say the relative frequency is moving towards 0.2, which is 1 out of 5, and I'd call that the theoretical probability. I.e., what you would expect to happen if this was fair. You would have 1 red out of 5. Okay, so it looks like it's probably reasonable at that point. Okay, question 13. Solve the simultaneous equations. Do not use trial and improvement. You must show your working. So we have, I'm going to write it down the side, we have that y is equal to 3x subtract 1, and we have that 5x subtract 2y is equal to 4. There are 2 equations, right? Now, there are various ways of doing this. What I think is probably the easiest is to notice here, you have got y, okay, as a subject of this formula. So instead of writing y in the second equation here, couldn't you just put 3x subtract 1 in its place, and then you would have an equation with all x's in it. So if you had labelled that 1 and 2, then you would say substitute equation 1 in 2. Now let's use brackets when we substitute. We still have 5x, we still have subtract 2, but this time, Instead of y, we're writing in brackets 3x subtract 1. And you still have your equals 4. Okay, now let's multiply this out. We have 5x. Now let's carefully do this here. This is negative 2 times 3x, which would be negative 6x. And we have negative 2 times by negative 1, which is plus 2. Still equal 4. Okay, 5x take away 6x is negative 1x, plus 2 equals 4. Then we could take away 2 off both sides, and we'd have negative x is equal to 2. So what's x? If negative x is 2, if we multiply both sides by minus 1, x would be negative 2. Right? And if x is negative 2, let's make sure we find y. Y from this equation is 3x subtract 1. So y would be 3 brackets negative 2 instead of the x, subtract 1. Y would be 3 times negative 2 is negative 6, subtract 1, which is negative 7. So the answers on x is negative 2 and y is negative 7, and you should check they work. Let's check they work here. If y was negative 7, we'd have negative 7 here, and we would have equals 3 times negative 2 is negative 6, take away 1 is negative 7, it works there. What about here? 5 times 2, 5 times minus 2 is minus 10, subtract 2 times y, or negative 2 times negative 7 would be plus 14. And if you do that, you would get the 4 that you're looking for on this side. So it does work here. Quickly, just want to show you another way in case you're not happy with the substitution method. What you could do is you could, if you've got y is equal to 3x subtract 1, and you've got 5x subtract 2y is equal to 4, you could get it so that you could actually get it so they both have x's and y's on the same side. So what you could do is you could, let's say, subtract 3x from both sides on this one here, and you would get negative 3x plus y is equal to negative 1. And then you might want to make the x or y numbers the same. If you multiplied this whole equation by negative 2, you would get negative 3x times negative 2 is 6x. Subtract 2y is equal to 2. That would be your equation 1. That would be your equation 2. And now you could subtract them from each other. So you might do 2 subtract 1. 6x take away 5x is 1x. Negative 2y subtract negative 2y is negative 2y plus 2y is 0. And 2 subtract 4 is negative 2. That gets me my x is negative 2. Summing it back in here gets me my y is negative 7. Okay, whichever way works. I would suggest the easiest thing is to spot that you have y the subject, therefore that can be stuck in place there instead of the y there. Okay, an equilateral triangle has an area of 36 centimeters squared. Equilateral, that means that side, and that side are the same. It also means that angle is 60 degrees, that angle is 60 degrees, and that angle is 60 degrees. Two of these triangles overlap to form a regular hexagon as shown. Work out the area of the regular hexagon. Okay, what could we do here? We don't know the length or the height of this triangle, so we can't do anything there. What we could think to ourselves is, what if we split this up here? What if we drew lines between each corner as follows? Okay, what if we did that? And I think it would be fair to say that it's obvious that this shaded part is equal to that shaded part, and this shaded part is equal to that unshaded part, sorry. Okay, so we are trying to work out the area of 1, 2, 3, 4, 5, 6 of the mini triangles. Now, if we then decide for ourselves, right, this is the area of the triangle we're trying to find. Okay, what if we we want 1, 2, 3, 4, 5, 6 out of 9. We want 6/9 of the 36 centimeters squared. Okay, because we want 1, 2, 3, 4, 5, 6 out of the 7, 8, 9 squares to work out the shaded area. Okay, so 6/9 of that, well, that's the same as 2/3 of 36, and 2/3 of 36 divided by 3 is 12 times 2, you get 24 centimeters squared. I think that's the easiest way to work a problem like this out. Alternatively, what you could have done is, if you realise the big triangle here is split up into 9, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, then one little square must be 36 divided by 9, which is 4 centimeters squared, and you want 1, 2, 3, 4, 5, 6 of those, so it'd be 6 times 4, which again is 24 centimeters squared. It's basically another way of doing the same as I did here. Okay, simplify the following. Now, I have done this on previous videos. You must now be in the habit of doing the right thing here. When you're asked to simplify algebraic fractions, what do you do first? The first thing you do is you factorize the top and bottom. Step 2, you then cancel. Okay, so let's factorize first. Anything going to 2x plus 3, anything going to 2x and 6, sorry, well, 2 does. And if 2x divided by 2 is x, 6 divided by 2 is 3, so it's plus 3. All over x plus 3 squared, which means x plus 3 times x plus 3, right? Now look, something cancels, and x plus 3 is multiplying on top and bottom, it cancels, so you're just left with 2 on top and x plus 3 on the bottom. That's your answer. Simple as that. No further work required. Question 16. Again, we have seen these questions come up before. You should be in the mode with these ones now. First thing I do is I want to get rid of that 2 there. So I multiply everything by 2, and I would get 2 on top. Still got my x plus 3 over 2. Subtract 2 here. Keep everything in brackets. 2x minus 1 over 3 is equal to 2 times 1, which is 2. Then you'll notice that the 2's cancel, and I have x plus 3 subtract 2, 2x subtract 1 over 3 is equal to 2. Now I decide to multiply everything by 3, okay, to remove the 3 on the bottom. So what would I get? Well, I would get 3, x plus 3, subtract, well, I'm multiplying this by 3. I'm just going to keep the 3 there for now. 3 times 2 on the top, and then times the 2x minus 1 all over 3 is equal to 2 times 3, which is 6. Now you'll notice that 3 and that 3 cancel. So actually, I've got 3, x plus 3, subtract 2, 2x subtract 1 is equal to 6. Now it's a simple algebra game. Expand the brackets and solve. That times that is 3x. That times that is plus 9. Negative 2 times 2x is negative 4x. Negative 2 times negative 1 is plus 2 is equal 6. 3x subtract 4x is negative x. 9 plus 2 is 11. Take away 11 off both sides. Negative x must be negative 5. And multiply both sides by minus 1. X therefore must be 5. Okay, so I think x is 5 is the answer. Does it work? 5 and 3 is 8. 8 over 2 is 4. Subtract 2 times 5 is 10. 10 take away 1 is 9. 9 over 3 is 3. So 4 take away 3 does give me 1. It works. I know I've got the right answer. Now, there are quicker ways of doing this, and I want to show you the quick way. I think that's a bit long and laborious. First thing I do here, make sure I put a bracket there and there. It makes everything go much smoother. First thing I do is I work out the lowest common multiple of 2 and 3. The lowest common multiple of 2 and 3. What number is the smallest that 2 and 3 divide into? It's 6. I multiply everything through by 6. So I get 6x plus 3 over 2, subtract 6, 2x, subtract 1 over 3 is equal to 6. Everything got multiplied by 6. 6 there, 6 there, 6 there. Then I can do a bit of cancellation because 6 divided by 2, this here is 3. Keep your subtract there. And 6 divided by 3 here is 2. And I get the same equation that I did previously, but in one line really, one or two lines rather than the lines I did before. Expand that out, cancel, simplify, etc. You will get the correct answer again, namely that x is equal to 5. Okay, simplify the following. 2x4y to the power of 3. Now, I want you to think here. Students will write this. They will write 2x7y cubed. They will write 2x12y cubed, etc. All of these are wrong. I'm going to write the right answer, and then I'm going to explain to you how you can remember it. The correct answer is 8y to the 8 x to the 12 y cubed. Okay, and I'm going to explain to you, if you're stuck remembering these, this is how you remember it. Look, this here is a bracket. It's telling you that everything inside that bracket is cubed, i.e. 2x to the 4 y gets multiplied by 2x to the 4 y gets multiplied by 2x to the 4 y, right? Now, you can do the numbers times each other. 2 times 2 times 2 is 8. X to the 4 times x to the 4. There are 4 x's times 4 x's is x to the 8 times another 4 x's is x to the 12. And then we've got y times y times y is y cubed, hence that. If you're good with your indices, the way you'll remember it is simply that everything gets cubed. Because it's in brackets, the 2 gets cubed, so it's 2 cubed. The x to the 4 gets cubed, and the y gets cubed. 2 cubed is 8. Power of the power rule, you multiply powers, so it's x to the 12, and y cubed stays as it is. Okay, so there are many ways of remembering that. Please get that right. Factorize fully. I talked about this in the last video. When it says fully and there's 2 marks, there is a number to factorize out and some algebra. Firstly, let's deal with the number. What goes into 2x squared and 32y squared? A 2 does. Factorize out the 2. 2x squared divided by 2 is x squared. 32y squared divided by 2 is 16y squared, and keep your subtract. Now, you wouldn't get 2 marks for something as simple as that. There must be another trick to it. Yes, there is. You should recognise this is a difference of 2 squares. It's something squared, it's x squared. Take away something else squared, namely 4y squared. When you see something like this, it factorises to a plus b, a subtract b. So keep the 2 where it is. This must be x plus 4y, another bracket, x subtract 4y. Okay? Because x squares to x squared and 4y squares to 16y squared. So this is a kind of tricky thing here. A lot of students will struggle with it. Try and be one of the students who gets those right. Match each of the following sketches to one of these equations. Okay. Firstly, before I even look at the sketches, I'm going to just draw them out for you. We should know how to draw all of these in theory. Okay, let's take this one here. I'm going to draw a quick axis here for A. Y equals mx plus c. It's in the right form. Well, if I rearrange it into negative 2x plus 2 even. It crosses at 2, and it's got a gradient of negative 2. As you go across one, it goes down 2. So it looks something like this. That's what graph A should look like. The next one, graph B. 2x, y equals mx plus c. It crosses at 2, but it's got a positive gradient of 2. So here it crosses at 2, but instead it goes up this way. So it would look like that. That would be B. Okay, let's do C. C is an easy one as well. Well, C is a quadratic, so it's a U shape or N shape. Because it's negative x squared, it is N shaped, and it crosses at 3. So actually, it looks something like that. Okay, D, I'm going to do D over here. We know that cubic graphs, in general, we should know that the x cubed graph looks like this. But this plus 4 means everything's been shifted up by 4, so it gets moved up by 4 units. And E, lastly, the 1 over x graph, we should know the 1 over x graph, y equals 1 over x, looks like this. And 2 over x looks very similar, just slightly steeper here. It's something like that, very similar shape though, something like that. So, knowing we can actually draw the graphs, when we see them, it should be easy for us. This one here, clearly like the cubic, but shifted up by 4, so it must be this one here, D. Next, this one here, well, it's the straight line graph, and it crosses at 2, and it's got a negative gradient, so it must be A. This one here, it's like the 1 over x graph, so it must be the 2 over x graph, it's E. And the last one is for, you know it's quadratic, but it's an N shape, so it must have a negative x squared, it's C. Okay, and you should have been able to get that, in particular if the diagrams are given to you. But I showed you, you should know how to draw those graphs anyway. Okay, question 19. In a triangle OAB, O to A is given by vector A, O to B is given by vector B. AN, the vector to get from A to N, is a third the vector to get from A to B. Okay, so if this length here is x, let's say, then this length here would be 3x, because this is a third of that one. Work out O to N in terms of A and B, simplify your answer. So we want to get from O to N. O to N. Okay? Right. How would we get from O to N? The first thing we would do, to get from O to N, that must be O to A and then plus A to N. i.e. this plus this there. Okay? Now, we know O to A, this one here is little a, and it's going in the right direction because it's going that way. Now, do we know A to N? We know nothing about A to N other than we know it's a third of A to B, because that's an important fact. It's a third of A to B. So this A to N, we can replace it by a third vector A to B. Now, maybe we might be able to work out what the vector A to B is. Well, if you want to get to A to B, well, yes, it's negative A plus B. It's negative A plus B. Or an easier way of writing that is B subtract A. So what we could do is we could therefore replace this third AB must be B subtract A. Okay? And therefore we've got A plus a third B subtract a third A. Okay? And we're nearly there now. You should write down the page. We've got 1A take away a third A. So 1 of something take away a third of something. So we've got 2/3 of that something, namely A. And we've got plus a third B. So the answer is 2/3 A plus 1/3 B for 4 marks. Next question. Okay, now this question, just looking at it instantly, is going to be a tricky question to understand. Just, bear with me on this one. It's 3 marks. It's not too bad if you don't fully understand it, but I think you might be able to if you listen in carefully. The graph of y is equal to x squared plus 2x subtract 3 is shown on the grid. Just before I launch into that, how would I draw that graph if it wasn't shown to me? Well, y is x squared plus 2x subtract 3. Okay, the first thing I would do is I would let x be 0 When x is 0, y is negative 3. So I know I would cross off that point there. Then I would let y be 0, and I would solve x squared plus 2x minus 3 is equal 0. I solve that by factorising. That would be x plus 3, x minus 1 is 0. So therefore, when y is 0, x is negative 3, or x is equal to 1. So negative 3, 0 is 1 point, and 1, 0 is another point. And I know it's a positive x squared, so I would draw a dotted line between them. Hence, I would get myself that there. Also, where's the bottom point here? Well, it's exactly halfway between negative 3 and 1. And you can see that would be at negative 1. And to get this coordinate, I would sub in negative 1 in here, and I would get negative 4 out if I wanted to find that as well. Anyway, that's not what this question is about at all, so sorry for going over that, but it's handy for your background knowledge to know that. By drawing an appropriate straight line, find the approximate solutions of the following. Now, this here has got nothing to do with this graph currently at the moment, nothing. We want to solve the equation x squared plus x subtract 5 is equal to 0. Now, we would like to use this graph here. How could I make this be that graph here, be this? What could I do to this, both sides of this equation that I'm trying to solve, to make it be that? Well, remember, what I do to one side, I do to the other. Imagine I added an x, and imagine I added a 2. And if I did that on this side, I would have to do that on this side. Just imagine I did that. Would you agree then, I would have still 1x squared, but this time plus 2x, and this time negative 3 plus 2, so negative 5 plus 2 is negative 3. And that would equal x plus 2. Okay, so I've done something to this equation I'm trying to solve. I've added x plus 2 to both sides, and now on the left hand side I have the graph that I have here, which is great. On this side I have the graph y is x plus 2. So if I've drawn this graph, I have the graph y is x squared plus 2x minus 3 on here. If I now drew the graph y is equal to x plus 2, namely crosses at 2, has gradient 1. As you go across 1, you go up 1. As you go across 1, you go up 1. If I drew that graph there, like that, like so, then the points where these graphs meet must be the solutions to this equation. And because I've done the same thing to both sides, must be the solutions to this equation. So what are the x solutions here? Well, this x value here is something like negative 2.8. And this x solution here, reading off there, looks like about 1.8. So the answers are 1.8 and negative 2.8, reading off the graph. Okay, very difficult question there, quite complicated. It's 3 marks, it's not the be all and end all, but see if you can understand that as best you can. And the last question, Wendy makes up a game to raise money for charity. These 4 cards are shuffled and placed face down. Okay, so it looks like you've got 2 spades and 2 hearts. Players pay £1 to play the game. The player turns over 2 cards. If the cards are the same, the player gets £2. Wendy wants to raise at least £50. Will she do this if 180 people play the game? Okay, with these questions, it's always useful to draw a tree diagram to show the possibilities. So you're picking a card. Now, say you pick the cards in 2 separate. You can pick them both at the same time, but one's going to happen before the other, isn't it? So you pick a card. Either you get a spade or a heart. Now, the probability of getting a spade is 2 out of 4, and the probability of getting a heart is 2 out of 4. Having picked a spade, you've instantaneously just picked one card up and you're picking another. You either get a spade or a heart next time, or you get a spade or a heart next time. What's the probability of picking another spade? Well, there's only 1 left out of 3, and how many hearts left? There are 2 out of 3. If you've picked a heart, there are still 2 spades left out of 3, and there's only 1 out of 3 left. Okay, so to win, the probability of winning, you have to get a spade or a heart. The probability of a spade is 2/4 times a third, which is a half, times a third, which is a sixth. And same thing for a heart here, it would be a sixth. Therefore, probability of winning must be a 6 plus a 6, which is a third, right? Okay, so your chances of winning are a third. Okay, let's. So if 180 people play, and they each pay how much do they pay? £1 times £1. She would have £180 in the pot. Now let's work out how much she would expect to have to give away. 1/3 of the time people will win. So the 180 people times a third, 60 people should win. Okay, and each time they win, they get £2. So the winnings must be 60 times £2, which is 120. So therefore, her profit, or how much money she makes, would be how much she got in, the 180, take away how much she gave out, the 120, is £60. And she wants to raise 50. Will she do so? Yes. Should do, with £10 to spare. Okay? And that's how you do it. I would always, with these ones, go for a tree diagram. It makes life a whole lot easier. Okay, that's everything for this particular video. Thank you for watching.